Course 1, Lesson 13 gives us ways to solve two types of problems we need to be ready for. The first are problems where we compare, such as in example 1, bottom of 68, there were 324 girls, 289 boys in the whole school. Alright, now what if we had to say how many fewer boys than girls? Notice boys are the smaller group. There's only 289, so we can say there are less, there are fewer. Now how many fewer is the same as asking what's the difference in amount? How many less here than here? What's the difference? And if you see the word difference, you should be thinking about subtraction. All right, we can follow a pattern greater lesser difference where we take the bigger amount, 324, we subtract the smaller amount, 289, to get the difference, which is the same as finding out how many fewer. You can show this shorthand with the first letters of those three words. So we subtract 324, 289, do some borrowing. Looks like we end up with 35 because 2 minus 2 is 0. 35 fewer, we could check that by typing it into a calculator and see that we longhand solved with subtraction correctly. So that's a subtraction pattern for solving when you're comparing two amounts. Check the answer. Looks good. Elapsed time will also have to do with subtraction in most cases, where we have the length of time between two events means elapsed time. I love this visual. It shows time is always, kind of going to the right if we think of it as a timeline. Earlier dates towards the left versus later dates to the right. And if you think of it as a ruler, that gap that we measure, like an inch or a centimeter, think of it as the elapsed time between that earlier and that later date. The earliest date you can remember, probably don't even remember, is your birthday. And to measure from today to your birthday, we put today's date at the top, which is the later date, further to the right. The early date we take away, the further to the left, which is your birthday. And what you'll actually find by subtracting, finding the difference in this later earlier difference pattern, is your age, right? That's one application for elapsed time problems. Example 2, read to yourself right here. Now, just pause if you need more time, but which is the later date? Year, to be more exact, 1620. We can treat it like it's 1620 right now as we subtract. Don't get thrown off that it's a year. And the earlier or farther away, more to the left on the timeline year is 1492 when Columbus sailed the ocean. So what was the difference in time, the elapsed time, the gap on the timeline between that earlier date and the later date? You put the later date on top and we solve like so. Okay, we did our borrowing. Take away looks like 128, don't forget to label, years earlier. And you could check that again by subtracting it on your calculator. Let's see that they got the same as us. They did. You can also check by adding to your earlier date the amount of years we say that elapsed to get you to that spot on the timeline and make sure it matches up with 1620. Abraham Lincoln was born in 1809, died in 1865. How many years did he live? Again, instead of today's date, we use a date in his lifetime, to be exact, the last date in his lifetime, and we subtract his birthday to find how old he was at a given time. Follow our four-step method where we identify the pattern, write our equation, which means a statement with operation and equal sign, solve, check, make sure it's reasonable. Why don't we pick letter A or B? Thank you.